Hello, we are discussing about the questions which came under GATE 2013 on the topic of electron devices. We are discussing about the 1 mark questions first. This is the third 1 mark question in the series. And please refer www.egate.ws for other video solutions on all topics. The question is, in a MOSFET operating in saturation region, the channel length modulation effect causes A. An increase in gate source capacitance, B. A decrease in transconductance, C. A decrease in unity gain bandwidth product, D. A decrease in output resistance. Once again the question is, in a MOSFET operating in saturation region, the channel length modulation effect causes. The right answer for this one is D. A decrease in output resistance. Channel length modulation will decrease the resistance at the output side whenever MOSFET is under saturation. We will see the reason behind this. Generally, we assume that drain current is constant under saturation region. That is true when the channel length modulation effect is neglected. Channel length modulation effect is modeled with the parameter lambda. This is what? With the parameter lambda. Lambda is treated as channel length modulation parameter. If it is neglected, lambda value is 0. If it is considered, lambda is not equal to 0. If lambda is 0, at that time ID is only function of VGS. It is not function of VDS. Since lambda is equal to 0, this term will disappear. So by that time ID is constant, it is independent of VD term whenever channel length modulation effect is ignored. But as the channel length modulation effect is considered, at that time the saturation current increases as VDS increases. So first conclusion is nothing but drain current is no more constant in saturation region when we consider channel length modulation effect. Channel length modulation, the meaning of this one is modulation in channel length. We assume that channel length is L, but the channel length is L physically, but practically under saturation the effective channel length has been reduced as VDS increases. That's why the effect is treated as channel length modulation effect. Just look at these characteristics. Whenever with respect to VGS is equal to, for a given VGS, that VGS we are assuming that one VGS2 is the value given. For VGS2, the output or drain characteristics are showing this one. Look at this curve, the second one. Whenever lambda is equal to 0, that is whenever channel length modulation is neglected, by the time ID is treated as constant. It is going to be constant even though the drain voltage increases. Drain current is constant even though the drain voltage is increases when channel length modulation effect is neglected. If we consider channel length modulation effect under saturation, it is no more constant, it is slightly increases. So for the given value of VGS, you will get more drain current at a particular value of VDS. At a particular value of VDS, if we consider channel length modulation, you will get more drain current than the drain current without channel length modulation effect. From this one, we can conclude 4 important points. First one, transconductance increases. Transconductance is indicated with GM. GM is equal to dou ID by dou VGS. Dou ID by dou VGS, for a given value of VGS, ID increases as VDS increases. That is, numerator part is increasing, so GM is going to be increases. Whenever channel length modulation effect is considered, transconductance increases. Second one, output impedance or output resistance, simply it is treated as RDS or RD, which decreases. RDS or R0, it is given as 1 by lambda ID. So because of channel length modulation, ID is going to be increasing. Since ID appears in denominator, definitely R0 is going to be reduces. Channel length modulation effect causes ID to increase, so that R0 is going to be reduces. So output impedance decreases because of channel length modulation effect. Gain bandwidth product will remain constant. So no effect of channel length modulation, gain bandwidth product is always constant. Fourth one, CGS and CDS under saturation. CGS is gate to source capacitance and drain to source capacitance. These two capacitances are treated as overlap capacitances. These two capacitances doesn't have any effect. They will be remain unchanged even though channel length modulation is considered or not considered. So the correct answer for these things: transconductance increases, output impedance decreases, gain bandwidth product remains constant, CGS and CDS doesn't have any effect. Out of all these conclusions, the correct answer is decrease in output resistance. Thank you.